This is the EE301 12-week review packet, and we're going to be looking at problem 2, parts A, B, and C. Find the impedance values of the given elements. So for the first one, you'll notice that this is an inductor. An inductor's impedance equation is as follows. ZL equals XL at an angle of 90 degrees. We can expand that with the reactance of an inductor equation into either omega L at 90 or 2 pi frequency L at an angle of 90. So we're given frequency in this one. So this is the equation that we're going to be using. So ZL equals 2 pi FL angle 90 equals 2 pi 60 times 132.63 times 10 to the negative 3, because that's millihenries, and that's at an angle of 90. And we'll just plug all that into the calculator, and we'll end up with around 50 at an angle of 90. It's also acceptable to use J. Both of these are acceptable answers, and the unit is ohms. So for the next one, a capacitor. Impedance of a capacitor on your equation sheet is XC at an angle of negative 90. XC, given that we have omega as our given variable, we know that it is 1 over omega C at negative 90. So 1 over omega, that's 235, over 193.42 times 10 to the negative 6 for microhenries at negative 90. And that gives 22 at an angle of negative 90, or negative J22. Both are acceptable answers. And again, that's an ohms. Now finally, we have our resistor here. Now resistors are always at an angle of 0. So the equation is just R at an angle of 0. So 80.5 angle 0, or just 80.5 is a perfectly acceptable way to write it. And that is how you solve problem 2, part A, B, and C.